Germany's war machinery was built on recovery and adaptation, on fast tanks, bold tactics, early victories that shocked the world, and no mercy. But success bred belief, and belief turned into obsession. Under Adolf Hitler and the Nazi Party, power stopped being about efficiency and became about intimidation. Bigger meant better. Heavier meant unstoppable. That mindset gave birth to the heaviest tank ever built, and in doing so, revealed the moment Nazi engineering crossed from dominance into delusion. It was not invincibility. It was a collapse. The German engineers stood in silence as the numbers came back. 188 metric tons. Not a typo. Not a calculation error. The tank was called the Panzer VIII Maus. That was the actual weight of the machine they had just finished building. No one had ever put something that heavy on tracks and called it a combat vehicle. The previous record holder wasn't even close. Modern main battle tanks that dominate battlefields today weigh somewhere from 60 to 75 tons, and those are considered massive. This thing was more than double that. It wasn't just breaking records, it was operating in a category that didn't exist before and hasn't existed since. The weight alone told you something had gone very wrong in the planning stages, or very right, depending on who you asked. But standing there, looking at the machine, one thing became clear. This wasn't just a tank. It was a statement about what happens when ambition stops listening to reality. The question wasn't whether it could fight. The question was whether the world it was built for could even support it. Roads weren't designed for this. Bridges certainly weren't. The infrastructure that armies relied on to move equipment across continents was about to meet something it was never prepared to handle. And the engineers knew it. They had known it from the beginning. But the project kept moving forward anyway, because someone at the top believed that overwhelming force could solve problems that logistics couldn't. What they built didn't just challenge the enemy. It challenged physics, engineering, and common sense. And that challenge was about to create problems no one had planned for. Within days of the completion of the first prototype, the problem became impossible to ignore. Every bridge they examined, every road they tested, every piece of infrastructure that connected one part of Europe to another failed the same basic test. The tank was too heavy. Standard military bridges, the ones engineers could assemble in hours to keep armies moving, had weight limits that topped out well below what this machine demanded. Civilian bridges were no better. Most of them had been built decades earlier for traffic that weighed a fraction of this. The realization hit hard. You could build the most powerful weapon in history, equip it with armor that nothing could penetrate, give it a gun that could destroy anything on the battlefield. None of that mattered if you couldn't get it to the battlefield in the first place. The engineers looked at their maps and saw a network of roads and bridges that might as well have been painted red with restriction signs. Moving the tank wasn't just difficult, it was borderline impossible using normal methods. Other armies could load their tanks onto trains, drive them across bridges, move them hundreds of miles in a matter of days. This one could not. Every route had to be studied. Every bridge had to be avoided. The entire concept of rapid deployment, the thing that made armored warfare effective in the first place, was out the window. So the engineers did what engineers do when normal solutions do not work. They stopped thinking about bridges altogether. If the world was not built for this machine, then the machine would have to work around the world. That decision led them somewhere no tank designer had seriously considered before. The solution they came up with sounded like something from a science fiction novel. If the tank could not cross bridges, it would cross rivers by driving along the bottom. Not floating, not using pontoons. Actually submerging and driving underwater like a submarine with tracks. The engineering team designed a snorkel system that could supply air to the crew and the engine while the entire vehicle sat beneath the surface. They worked out the seals. They tested the pressure tolerances. They even figured out a way for one tank to provide electrical power to another while both were submerged, in case one lost power mid-crossing. On paper, it was brilliant. In practice, it was one of the most complicated mobility solutions ever attempted for a ground vehicle. The crew would have to trust that every seal held, that the snorkel stayed above water, that the riverbed could support the weight without the tank sinking into soft mud and getting stuck. They would be blind, moving slowly through water, completely vulnerable if anything went wrong. No quick escape, no backup plan. Just hope that the engineering held up under conditions most tanks would never experience. It was creative. It was ambitious. It was also a perfect example of how far the designers were willing to go to make this machine work, even when every practical consideration said they should not. But at least there was one area where compromise did not exist. The gun they mounted on this tank left absolutely nothing to chance. The main weapon was a 128mm gun, a piece of artillery that belonged on coastal defenses, not a mobile vehicle. Allied tank crews were operating machines with 75 or 76mm guns, and those were considered effective. This was nearly double the caliber. The German engineers did not stop there. They added a secondary 75mm gun, the same size as the primary weapon on most enemy tanks, just as a backup. The firepower was so excessive that it crossed into absurdity. This tank could engage enemy armor at ranges where the enemy could not even see it yet, let alone fire back. Every shot it fired carried enough force to punch through any Allied tank from the front, sides, or rear. There was no angle of attack where an enemy vehicle was safe. The gun was designed to eliminate threats before they became threats. One shot, one kill, at distances that made return fire impossible. It was overkill in the purest sense of the word, and everyone involved knew it. But that was the point. The tank was not just supposed to win fights. It was supposed to make fights unnecessary by being so overwhelmingly powerful that nothing dared approach it. On paper, that logic held. In reality, the gun's effectiveness depended on one critical assumption. The tank had to reach the battlefield first. And that was about to become the single biggest problem the designers could not solve. The official top speed was listed as 13 kilometers per hour on flat, solid ground under perfect conditions. That's roughly 8 miles per hour. A person jogging could keep pace with it. In real-world conditions, off-road or on uneven terrain, the speed dropped even further. The engine, as powerful as it was, spent most of its energy just moving the weight. Fuel consumption was catastrophic. The tank burned through its supply so quickly that every movement had to be carefully calculated. You could not just drive it somewhere and hope for the best. Every kilometer traveled meant logistics teams scrambling to position fuel supplies along the route. Every breakdown, and there were many, meant the entire operation ground to a halt. Speed was not just a performance metric, it was survival. Tanks that could not reposition quickly became stationary targets. They could not respond to breakthroughs. They could not retreat when situations turned bad. They sat there, waiting for the enemy to figure out how to deal with them. And enemies always figured it out. The slower the tank moved, the more time they had. Air support could be called in. Artillery could be repositioned. Flanking maneuvers could be coordinated. The tank's armor and firepower became irrelevant if it could not control when and where the fight happened. Speed was a decisive factor. The designers had built a weapon that could dominate any battle it reached, but getting it there was something else entirely. And the man who approved this project did not care about those details. He cared about results, and he expected them no matter what the engineers said. The project never would have existed without one man's approval. When the proposal landed on his desk, the reaction was immediate and enthusiastic. He loved the concept. A tank so massive, so heavily armored, so powerfully armed that it would be invincible on the battlefield. The psychological impact alone would be worth the investment. Enemy troops would see it coming and lose the will to fight. That was the theory he believed in. That was the vision he approved. Adolf Hitler did not just greenlight the project, he championed it. He saw these massive weapons as symbols of German engineering superiority, proof that willpower and ambition could overcome any obstacle. The engineers tried to explain the problems. They laid out the mobility issues, the fuel consumption, the infrastructure limitations. None of it mattered. When the person at the top of the chain wants something badly enough, objections become background noise. The project moved forward, not because it made tactical sense, but because it satisfied a belief that wars could be won through shock and overwhelming force. Hitler's fascination with superweapons was not new. He had pushed for massive artillery pieces, oversized aircraft, submarines that pushed the limits of what was possible. This tank fit perfectly into that pattern. It was big, it was dramatic, it was something the enemy did not have. The fact that it might not actually work in combat was treated as a problem to be solved later, after it proved its worth. The engineers went back to their workshops with approval in hand and doubt in their minds. They had the resources, they had the mandate. What they did not have was confidence that any of this would matter once reality set in. But they built it anyway, because orders were orders, and the consequences of those orders were about to become very clear. Production never scaled beyond the prototype phase. 2 hulls were completed, 2 turrets were assembled. That was the entire output of a project that consumed enormous amounts of steel, labor, and engineering resources. By the time the war entered its final stages, German forces were desperate for equipment. They needed tanks that could be built quickly and deployed in numbers. What they had instead were 2 experimental machines that could not be mass-produced and would not have been useful even if they could. As Soviet forces closed in on the testing grounds, the decision was made to destroy everything rather than let it fall into enemy hands. 1 hull was blown up, 1 turret was demolished. The parts that remained were scattered, incomplete, and abandoned in the chaos of the collapse. The entire project amounted to nothing in terms of battlefield impact. No combat deployments, no confirmed kills, no tactical victories. Just 2 prototypes that never saw action and were destroyed by the people who built them. All that engineering brilliance, all that investment in materials and manpower, ended with explosives and retreating troops. It was the final proof that the project had been doomed from the start, not by enemy action, but by its own impossibility. The war moved too fast. The resources were needed elsewhere. The infrastructure could not support it. Everything the engineers had warned about came true, and the machines that were supposed to change the course of the war ended up as rubble. But not all of it was destroyed. Enough pieces survived the demolition to give the wreckage a second life in a place far from where it was built. The Soviets arrived at the testing grounds and found the remains, destroyed vehicles, scattered components, pieces of something that clearly had been massive. They collected what they could. 1 partial hull, 1 damaged turret, parts from different prototypes that had never been meant to go together. The decision was made to combine them into a single composite vehicle, a Frankenstein version of what the original designers had intended. Soviet engineers reassembled the pieces, filled in the gaps, and created something that could at least be displayed, even if it would never run again. The result was shipped to the Kubinka Tank Museum outside Moscow, where it sits today. It is the only surviving example of the heaviest tank ever built. The tank became a museum piece, not because it was significant in combat, but because it was significant in failure. It represents everything that went wrong with the superweapon philosophy. Visitors walk around it, stare at the size of the gun, the thickness of the armor, the sheer mass of the thing, and the reaction is always the same. How did anyone think this would work? The museum keeps it as a historical artifact, a reminder of what happens when ambition ignores practicality. It is not a trophy, it is evidence. The only reason it exists at all is because the Soviets saw value in preserving the wreckage, not as a weapon, but as a warning. And standing still, stripped of any pretense of combat effectiveness, it finally found a role it could fulfill. But even in its preserved state, the question remains, could it have ever been stopped if it actually made it to battle? The armor was the one thing the designers got absolutely right. Frontal protection measured up to 240 millimeters in some sections. To put that in perspective, most Allied anti-tank guns were designed to penetrate armor that was half that thickness at best. A direct hit from the front with standard ammunition would do nothing. The shell would bounce off or shatter against the steel without causing meaningful damage. Tank commanders on the Allied side would have had to completely rethink their tactics if they ever encountered this thing. Frontal assaults were suicide. Standard engagements at medium range were pointless. The armor made the tank nearly invulnerable to ground fire from the angles it was designed to protect. But invulnerability from the front did not mean invulnerability everywhere. The sides were thinner, the rear was weaker, the top was exposed to air attack, and by the time this tank was being built, Allied air superiority was absolute. Dive bombers, rockets, artillery strikes from above, all of these could disable or destroy it without ever engaging the frontal armor. Flanking maneuvers were still possible if the tank could not rotate fast enough or reposition to protect its weak points. Mechanical breakdowns were a constant threat, and a tank that could not move was just a stationary bunker waiting to be bypassed or destroyed. The armor gave the illusion of invincibility, but that illusion only held under very specific conditions. Step outside those conditions, and the protection meant nothing. The real question was not whether it could survive a fight. The question was whether it could survive everything that came before and after the fight. The tank became a symbol long before it became a museum piece. It represented the moment when engineering ambition stopped listening to strategic reality. The designers built something technically impressive. The armor worked, the gun worked, and the systems, as complicated as they were, functioned. But none of that translated into battlefield effectiveness, because the entire concept was flawed from the beginning. Wars are not won by individual machines, no matter how powerful. They are won by logistics, mobility, adaptability, and the ability to produce and deploy equipment where it is needed. This tank failed every one of those tests. It consumed resources that could have built dozens of smaller, more practical tanks. It demanded fuel and maintenance that could not be supplied in combat conditions. It required infrastructure that did not exist. The project drained time, steel, and labor from a war effort that was already losing ground. Every hour spent on this machine was an hour not spent on something useful. Every kilogram of armor plating was material that could have reinforced positions or equipped other vehicles. The opportunity cost was staggering, and the return on that investment was zero. It became the textbook example of what happens when you prioritize spectacle over substance, when you confuse technical achievement with tactical value. The heaviest tank ever built did not fail because it lacked power. It failed because power was never the problem it was designed to solve. The real problems were speed, logistics, production capacity, and strategic flexibility. On every one of those measures, the tank was worse than useless. It was a monument to the kind of thinking that loses wars. It did not fail because it was weak. What failed was the idea behind it. Wars are not won by the biggest machine, but by movement, supply, and timing. This tank asked the battlefield to adapt to it, and history never does. In the end, the heaviest tank ever built became a monument, not to victory, but to ambition outrunning reality.